So good afternoon, everyone. My name is Xianfei Yin. I'm assistant professor at the City University of Hong Kong. So this work is mainly done by my student, but he cannot come here, so I will present him. The title of the topic is Tailored Vision Language Solution for Comprehensive Pattern Identification on Construction Sites. So construction site is a very complicated environment. We have a lot of safety hazards on construction site, including falls from height, slips, and electricity hazards, things like that. So one way we can improve the safety on construction site, which is also one of the popular theme previously, to use computer vision to detect PPE violation. So we use on-site CCTV camera to capture videos of workers and equipment to detect if there are related violations using computer vision technologies. The problem with this type of technology is we need a lot of data to train the model, and we can only detect a limited number of categories for the safety hazards. So the solution we are proposing is based on vision language model. So vision language model is a subset of large models, similar to large language model, but vision language model has the ability of processing images. So it can understand the semantic meaning within the images. So we try to use this technique with less data and train a smarter
building information model is an essential component
detector
for
automating
the process of
chat
building inspection.
To understand what has happened within construction video,
plan and
to generate humanly understand report that is in text format.
Ground sampling distance.
So this is a framework of our research, started from selecting a pre-trained vision language model. So for us, we use a open access vision language model for Qihua version 2, which is a large model developed by Alibaba Group in China.
So from the
first step, we constructing a dataset. And then we use it dataset to fine-tune the vision language model. And finally, we use the model to generate a construction hazard report. So I will break down them a little bit. The first step, we construct this dataset. Contains 1,308 images covering 32 construction hazard categories into 4 major types, including PPE-related, worker behavior-related, tools and equipment-related, and environmental-related. So within these 4 major types, we have more detailed
operational
categories.
Mainly
so compared with previous research, this 32 construction had
most of the drones
much
now
more. The number of
the
categories is much more higher compared with previous research.
Max, so
and for each of the category, the number of samples varies from 10 samples to 30 samples.
And finally, the laboratory and
so the step 2 is that we use this dataset to fine-tune the vision language model. So we use LoRa technique to fine-tune the model. So basically, the LoRa, the idea of the LoRa is we don't retrain the language model, vision language model, just
automating the
enrich the original model with specific domain knowledge. So as you can see on this side, this is the original weight of the vision language model. We don't touch it, and we only train on your right-hand side a low-rank matrix that contains domain-specific knowledge. So we train this small subset that reduce the computing resources requirement. After we fine-tune the model, basically the vision language model can understand domain knowledge of images. So the domain knowledge in our case is the safety hazard issues. And we design the prompt so the vision language model can actually generate text message about
drone that
the
use
safety header within the image.
based on the
And then we
distance
use another
that we
large language
calculated
model to
earlier.
format the output of the vision
And the
language model
second,
to get a
stage,
standard format
which is the simulation
message of this description.
We start
So until now, we
on the building information model
extracted
of the
information from
building
images,
that we
but for videos,
to inspect.
videos
If you don't
compare
get the
contains
BIM
a set of
model is not
images, so
available,
we
it
just
can be
extract
created from
some video
the
frames
3D,
at a certain
drawings
time step,
by
and
taking
for
manual
each of the video
measurement.
frames, we can
Basically, in the
detect the
3D
safety
model,
header
we
within
need
that
a simple
video frame,
3D model.
and the associated description will be generated. And finally, we will use large language model to summarize all this information regarding each of the frame and give us
After we simplify and
a final construction header with a specific design format.
Facades of the building with the
So some of the results
that
here,
planning
these are the CCTV collected images of inside. So as you can see, the CH can understand what is happens within the image, and it can give you message of the safety hazard. For example, the first one is that safety helmet worn, but chain strips is not secure. The worker not wearing high visibility vest. So things like that can be generated by the vision language model.
Points at a distance.
And the final result, the final output is safety header report. So the report is basically a summary of the whole CCTV video. So we design the report in a format. We start with an overall description of the construction header. So it gives you an overview of how many safety headers detected within the video. And then some of the details will be listed in the table.
I wanted to ask if you could go back to the first slide
so,
to see
the format can be fully covered.
you gave to implement
users require
because
design your
it interests me because the UK is no longer in the
format of the
they look very similar to the
report.
So yeah.
So some of the results, we tested the performance of the vision language model. So
could you hear the question?
On the upper section is the vision language model before fine tuning. Regarding each of the header categories, preceding, recall, and advanced. So the lower section is after fine tuning, so we can see.
So you cannot share your slides
with these performance indicators for each of the.
because that raised the question from a slide, right?
And we also take different versions of the vision language model. Q1 version 2, Q1 version 2, 2B, 7B. So the 2B and 7B meet the parameters that the model has. So 7B clearly means that the model have more parameters. And also Lava 1.5 7B, we found out that
we have the slides here, don't worry.
Version 2 7B version is the best performance model that we have.
Which one you're looking for?
We also tested the few short learning ability. So as you can see, if the model with no sample provided, compared with 2 samples provided here, the improvement is around 55% with only 2 samples provided for this model.
This study I worked on flat.
And we further tested the robustness of the model. So we manipulated the original video frames, make it low light or cookie, and we found out that the best performance model can have a very stable output.
Can you hear me?
As you can see the orange ones here.
So did you evaluate on just doing fine tuning and then evaluate with just doing drag?
Regarding
the
robustness.
Any benefits over doing one?
So some of the lessons learned for this kind of model, the prompt design is very important.
And don't worry, I will read your paper and go through it. You don't have to explain anything. Thank you very much.
And the larger pre-trained VLL performs better in construction hazard detection. So also the LoRa
Yeah,
technique.
so because we are running out of time, thank you for your time.
Accelerates the
We are
recognition
going to the
without
next
compromising
presentation. Thank you.
quality and things like that. So that's all for my presentation. Thank you.